All right. Well, thank you so much for the opportunity to brief you on what my office is all about. Happy to be the first one up here. First of all, before I get into the scope of work we have in my office, which is the Office of Advanced Fuels Technologies, or NE42. And again, my name is Bill McCaughey. Before I begin, I just want to say that we in the R&D programs really value the contributions made by the universities, especially in my office in the in advanced fuels areas. We really work hard to bring in the best projects that mesh well with the R&D priorities we have. We incorporate them into the R&D programs. We've set up workshops to share information among the universities that are doing similar projects in major topics, major scopes of work, such as silicon carbide. And we also look to, we also value the integrated research projects, such as the one we have ongoing right now with MIT, with the MIT reactor, which is to establish a new loop of great interest to not only the lab researchers, but also industry, the industry fuel suppliers. So with that, let's move on to there's the scope of work for my office. You can see fuels is there, and we have fuels as a topic area we have every year. We have two other areas of work in my office, however. One is systems analysis and integration, and the other is the high assay low enriched uranium availability program. And I'll start with those two. Next, please. So systems analysis and integration, it's a relatively small program. It has two real areas of focus. One is on nuclear energy system performance, and the other is on economic and market analysis. In the energy system performance, what we're doing there is we're looking to primarily what's the nuclear energy contributions to address climate change and decarbonization. We assess the emerging nuclear energy technologies. There are so many advanced reactor concepts out there with many different types of reactors that use different types of fuel, have different fuel cycles, and that's what this systems analysis and integration program is all about, is to assess those differing fuel cycles as far as the material flows, what's needed in the front end, what's needed in the back end, costs, technology gaps, and those sort of assessments. The second area is the economic and market analysis, and this is where we do techno-economic modeling of these systems. We have nuclear cost modeling, and we do energy market analyses. We have one thing that this program does well is we have a multidisciplinary approach to things, where we have the economics, we have the technologies, we have the fuels, and they all come together and do the analyses that are needed to inform our R&D programs in the Office of Nuclear Energy. Next, please. So the other major area in my office is the high assay low enriched uranium availability program. Almost all of the advanced reactor designs out there use or are planning to use high assay low enriched uranium, which is uranium enriched in U-235 between 5% and 20% enriched. Now, the existing light water reactors use fuel enriched to up to 5%. So high assay low enriched uranium is above 5%. And most of these advanced reactor fuels are up in the 10 to 20% range. And we do not have currently a commercial supplier of high assay low enriched uranium in the United States. So that's what this program is all about. It's to build that capacity or that production capacity in the U.S. for these advanced reactor developers. We are doing two things right now in the near term. We do have small quantities of enriched uranium in the DOE inventories at various national laboratories, and that would be suitable to produce small quantities of high assay low enriched uranium in the near term. This would be primarily for fuel qualification, small quantities for the vendors to be able to do the experiments needed to qualify their fuel for use in their reactors. We also have a enrichment demonstration program going on at Piketon, Ohio, where this year we are finishing the construction of that. We'll be putting that into operation and demonstrating that facility can produce the high assay low enriched uranium. It's the first facility in the U.S. to be licensed by the Nuclear Regulatory Commission for the production of high assay low enriched uranium. In the longer term, what we're doing is working with the private sector, because this ultimately has to be a commercial enterprise. The government is not going to be in the business of producing high assay low enriched uranium long term. So we're working with the private sector to build out that production capability, and also all of the supply chain issues that go along with it, such as transportation, deconversion, and that sort of thing. Again, this area and the previous area, we don't have any work scopes proposed for the universities to support these areas. Next, please. Finally, advanced fuels. And so we do have in this the current version of our scope of work, we have topic area 5, which is all about fuels. We've singled out 5 areas. The 3 that are highlighted are in my office: accident tolerant fuels, silicon carbide fuel cladding, and metallic fuels. The other 2 are also in the topic area 5 for fuels, and those are in other offices: the TRISO particle fuels, in which you'll hear from after me, NE52, and then the salt fuels for molten salt reactors in NE43. I'm not going to go into a lot of detail on these, because you've got the I believe you've got the scope of work already for these topic areas, and we have a little description of them, and there's going to be another webinar later to address any questions you might have in these areas. So that would be it for my office. Thank you. Thank you for your attention, and of course, if you have any questions, I'd be happy to take them. You could email me anytime. So thank you.